1, it says, in the table, find as many patterns as you can. Use one or more tables to help you complete the table and be prepared to explain your reasoning. Okay, so basically, I copied down what's in the book. Okay, sorry, it's kind of small. Let me go ahead and zoom in for you. I think I can do that. Okay, so each number is half the previous number. We can find the next number by multiplying the current number by 1/2 or dividing by 2. Okay. The non-zero digits of the decimals are powers of 5. Each time there is an additional decimal place. Okay. And then over here, I wrote this down for you. So this is just another way of looking at the problem. Okay, and so here, let's go ahead and write 0.0625. Okay, and then for the next one, let's go ahead and write 0.03125. Okay, so take a look at the information there to see if you can come up with the same answers. Okay. The next one. The value of some cell phones changes exponentially after the initial release. Here are graphs showing the depreciation of 2 phones 1, 2, and 3 years after they were released. Okay, we can see that on the on the y-axis we have the value in dollars, and then on the x-axis we have time in years. Okay, so which phone is more expensive to buy when it is first released? Okay, so we're going to look at the y-axis, okay, because that's our value, right, in dollars. Change the color. Okay, and so for this one, A costs $1,000. Okay, and B costs $840. Okay, so A is going to be more expensive. How does the value of each phone change with every passing year? Okay, so it looks like the value of, so if we look after 3 years, okay, we have $216 for phone A. And then for phone B, it looks like we have $354. Okay, so it looks like A is depreciating more quickly than B. Okay, so that's all we need to put for that one. Which one is falling in value more quickly? Explain or show how you know. Okay, so let's look at phone A. I'll do the work up here. All right, so phone A loses $400 in the first year. Okay, and so what percent is that? So what we can do is we can say that 400 is equal to what percent of 1,000? Okay, because we want to find out what percent that is. So 400, this is going to equal 10x. We divide both sides by 10. and then x is equal to 40%. Okay, and then 40% is going to equal 2/5. Okay, and so that is A. And then let's look at the second year. Okay, it's going to lose, it loses, looks like it's going to be 240 in second year. Okay, so that's going to be 240 is equal to what percent of, now we have 600. Okay, and so this is also going to be 40% if you do the math. Okay, now let's take a look at B. Okay, I'll do that down here. Okay, so B loses $210 in the first year. Okay, which is 25%, or 1/4. Okay, and then it's going to lose $157.50 in the second. Okay, which is 1/4 of $630. Okay, so which one is falling in value more quickly? It looks like A. All right, the next one. We've got, if the phones continue to depreciate by the same factor each year, what will the value of each phone be 4 years after its initial release? Okay, so what is the value of each phone after? Okay, so we see how much it's falling in value, okay, for number 3. But what is remaining? Okay, so for A is going to be 3/5 times 216 equals $129.60. Okay, for B, we have 3/4, okay, times $354.38, which is approximately $265.79. Okay, so that is how much they are worth. And then for each cell phone, write an equation. Okay, so that relates the value of phone in dollars to the year since release. Use V for the value of phone A and W for the value of phone B. Okay, so V is equal to 1,000, that's the initial price, right? Times 3/5, and then the years is T. Okay, and then for our next one, we have W is equal to 840 times 3/4 T. Okay, so those are the equations that relates the phone value of the phone in dollars. Okay, so this isn't how much it's been reduced, it's how much it's worth. Okay, so for the next one, you're going to have to go ahead and do the technology on your own. Okay, but then what I'll do is I will write down some answers for you here. Okay, so A. Okay, so we have V is equal to 933 minus 259t. Okay, and then B, W is equal to 816 minus 661, sorry. Okay, so those are the two equations that you should get when you use the technology. Okay, and then let me go ahead and put the next answer in here for you. Okay, so here, a linear model would quickly lead to negative phone values, which we're not going to have. Okay, and so that's why the exponential is going to be better, because phone A would cost about $103 after negative $103 after 4 years. Okay, and that just doesn't make sense. It's going to make more sense that the phone would lose a fraction of its value each year. Okay, so those are going to be the answers for that question. Okay, so make sure you get the cards if your teacher has them, and complete 6.3. As always, take a look at the lesson summary to help you review the information we just went over with.